So, you've probably seen one of these before, or maybe you even use one every single day. This is a flat iron, also known as a hair straightener. Its main job is pretty simple: to take curly, wavy, or frizzy hair, and using the magic of heat make it smooth, straight, and sleek. But have you ever stopped to wonder what's actually going on inside this thing? How does it transform your hair from a wild mane into a perfectly polished style in just a few minutes? It's not magic, it's science and some really clever engineering. Today we're going to do a deep dive into the anatomy of a flat iron. We're going to take this thing apart, well, maybe not literally this one, but we'll use some awesome graphics and animations to explore its guts. We'll look at the heating plates, the temperature controls, the power source, and all the other crucial components that have to work together perfectly to get the job done without, setting your hair on fire. It's a fascinating piece of everyday technology that's packed with cool principles of physics and material science. By the end of this video, you'll not only understand exactly how your flat iron works, but you'll also appreciate the engineering that goes into making it a safe and effective tool. It's going to be a fun journey into the science of hairstyling. And hey, if you're into learning how everyday things work and enjoy breaking down complex topics into easy-to-understand pieces, do me a huge favor and hit that subscribe button for Academic 51. You won't regret it. Alright, let's start with the most critical part of the entire device: the heating plates. These two smooth, flat surfaces are where all the action happens. They are the only parts that actually touch your hair, and their job is to transfer a precise amount of thermal energy to your hair strands. To do this effectively, they need to heat up quickly, and more importantly, evenly. If one spot on the plate is hotter than another, you get inconsistent results and can even cause significant damage to your hair. It's like trying to cook a pancake on a warped pan. Some parts get burnt while others are still raw batter. So, how do they get hot? Hidden just beneath these plates are a couple of super efficient heating elements, usually made of a ceramic material called a PTC heater, which stands for positive temperature coefficient. This material is super cool because it's self-regulating. As it heats up, its electrical resistance increases, which naturally limits the current flowing through it and prevents it from getting dangerously hot. This is a brilliant, built-in safety feature that ensures the temperature stays stable. The heat from these PTC elements is then conducted through the plates to your hair. The material of the plates themselves is also super important. You'll often see them made from ceramic, tourmaline, or titanium. Ceramic is great because it distributes heat very evenly and produces negative ions, which help to smooth the hair's cuticle and reduce frizz. Titanium is a fantastic conductor of heat, meaning it heats up incredibly fast and can maintain high temperatures, which is ideal for very thick or coarse hair. Tourmaline is a crystal that's crushed and coated over the plates, and it's a champ at producing even more negative ions for an extra smooth, shiny finish. The choice of material is a key engineering decision that directly impacts performance. Now, heating the plates is one thing, but controlling that heat is where the real precision comes in. Not all hair is created equal. Fine, delicate hair requires a much lower temperature than thick, coarse, or curly hair. If you use a temperature that's too high on fine hair, you risk literally frying it, causing irreversible damage. On the other hand, if the temperature is too low for coarse hair, you'll have to make multiple passes over the same section, which also leads to damage. This is why temperature control is such a vital feature on any good flat iron. So, how does the flat iron know what temperature it is and how to hold it steady? This is the job of a tiny but mighty component called a thermistor. A thermistor is a type of resistor whose resistance changes significantly with temperature. It's constantly measuring the temperature of the plates and sending that information back to a small microprocessor, the flat iron's brain. This little computer chip is programmed with the temperature settings you see on the dial or digital display. It's a classic feedback loop. Here's how that loop works. You select your desired temperature, let's say 365 degrees Fahrenheit. The microprocessor tells the PTC heaters to turn on full blast. The thermistor measures the plates heating up rapidly. As the temperature approaches 365 degrees, the microprocessor starts to pulse the power to the heaters, turning them on and off very quickly, to gently bring the plates to the target temperature and hold them there. If you straighten a section of cold hair and the plate temperature drops, the thermistor detects this instantly, and the microprocessor sends more power to the heaters to bring it right back up. It's a constant, high-speed balancing act. Of course, none of this heating and temperature regulating magic could happen without a steady supply of electricity. The journey of power begins at the wall outlet and travels through the power cord to the internal circuitry of the flat iron. The cord itself might seem like a simple wire, but there's some clever design here too. Most quality flat irons come equipped with what's called a swivel cord. This is an absolute game changer for usability. It allows the cord to rotate 360 degrees where it connects to the handle. This simple swivel mechanism prevents the cord from getting tangled, twisted and kinked as you maneuver the flat iron around your head. If you've ever used an appliance with a fixed cord, you know how frustrating it can be when it wraps around your arm or gets caught on itself. The swivel cord allows for complete freedom of movement, whether you're straightening, curling, or creating waves. It's a small detail that makes a massive difference in the user experience and also improves the lifespan of the cord by reducing stress on the internal wires at the connection point. Once inside the flat iron, the electricity from the cord is directed to a small printed circuit board, or PCB. This is the central hub that houses the microprocessor, the thermistor's connections, and all the other electronic components that manage the power. The PCB acts like a traffic cop, directing the appropriate amount of voltage to the PTC heating elements based on the instructions from the microprocessor. It also powers the indicator light and the digital display, if the model has one. It's the unseen nerve center that brings the whole device to life. We've talked a lot about the incredibly hot parts of the flat iron, with plates reaching temperatures upwards of 450 degrees Fahrenheit or 230 degrees Celsius. That's hot enough to cook food. So, a huge engineering challenge is to contain all that intense heat and ensure the part you're holding, the body and handle, stays cool and safe to the touch. This is achieved through a combination of smart material selection and clever structural design. The outer casing of a flat iron is almost always made from a type of high-grade, heat-resistant plastic. These are special polymers like Ryton or Valux that have a very high melting point and are poor conductors of heat. This property is called low thermal conductivity. While the plates just millimeters away are scorching hot, this plastic shell acts as a powerful insulator, preventing that heat from reaching your hand. It's the same principle used in the handle of a cooking pot or the heat shield on a spacecraft. But it's not just about the material. The design often incorporates an air gap between the internal heating assembly and the outer handle. Air is a surprisingly effective insulator. By creating this buffer zone of trapped air, engineers can further reduce the amount of heat that transfers from the hot components to the exterior casing. You might also notice that the handle is ergonomically designed. A lot of thought goes into the shape, weight distribution, and texture to ensure it provides a comfortable, secure grip, reducing hand fatigue during use and minimizing the risk of accidentally dropping a very hot appliance. Finally, let's look at one of the simplest yet most essential safety and usability features on the flat iron: the indicator light. This small LED light serves a couple of very important purposes. Its most basic function is to provide a clear visual confirmation that the device is on and receiving power. This immediately answers the question, is this thing on? And helps prevent you from leaving a powerful heating appliance plugged in and active by mistake. It's a fundamental safety check. But on most modern flat irons, the indicator light is a bit smarter than just an on or off signal. It often works in tandem with the temperature control system to let you know the status of the heating process. When you first turn the flat iron on, you'll often see the light blinking or pulsing. This blinking is the universal signal for heating up. Please wait. It's a visual cue that the plates have not yet reached the target temperature you selected. Trying to use the iron while it's still blinking will lead to poor results. Once the thermistor confirms that the plates have reached the desired temperature, the microprocessor sends a signal to change the indicator light's state. The blinking stops and the light becomes solid. This solid light is your green flag telling you, I'm hot and ready to go. Some more advanced models might even use different colors, like changing from red to green to indicate their status. It's a simple, intuitive, and language-independent way to communicate critical information from the machine to the user, ensuring both safety and optimal performance. And there you have it. The complete breakdown of how a flat iron works. It's so much more than just two hot plates. It's a beautifully engineered system of self-regulating heaters, precise temperature feedback loops, advanced material science, and thoughtful ergonomic design. all working in perfect harmony to give you that sleek, straight hair. From the PTC heaters and the thermistor brain, to the insulating handle, and the simple but smart indicator light, every single part plays a crucial role. Hopefully the next time you use one you'll have a newfound appreciation for the clever science packed into this everyday device. I had a blast taking this apart with you today, and I hope you learned something cool. If you enjoyed this deep dive and want to see more videos where we break down the science and engineering behind the technology we use every day, make sure you're subscribed to Academic 51. We have a ton of exciting topics lined up that you won't want to miss, so hit that subscribe button and ring the bell to get notified. Your support helps us keep making these videos. Thank you so much for your curiosity, and for spending this time with me. It's viewers like you that make this all worthwhile. Let me know in the comments what everyday object you want us to deconstruct next. Until then, stay curious, and I'll see you in the next video.